Hello, good morning everyone, and welcome back to mathematics class. So, how was your holidays, my dears? I hope you have enjoyed well and you are fit and fine at home as well. Okay, so let's resume our classes. This is the second chapter for our periodic test 2. I have given you I'm I have given you three chapters for periodic test. The first one is mensuration, what we have already completed before our puja vacation. The second chapter is cubes and cube root, as you can see on your screen. And the third chapter is comparing quantities, which we will do after completing this chapter. Okay? Okay, without any delay, let's start our classes. So the name of the chapter is, you can see on your screen, cube and cube root. And please mention the day and date. This is an introduction video, so you don't have to copy this. I'll clear the concept of this chapter in this three videos. I'm going to make a three introduction video for this chapter. You don't have to write it in your copy. You just go through the videos twice and thrice, so all your concepts will get clear. Whatever we are going to do in this chapter, there is a there is here it is a short explanation on those. So if you understand these three videos, you can easily solve the problems. So this is the introduction videos. I am again telling you, I am going to give you the three introduction videos for this chapter, and you don't have to copy this. You just go through again and again to clear your concept for this chapter. Okay, let's start. So the name cube and cube root. Let's start with the cubes. Okay, in our previous classes we know what is a cube. It's a geometrical figure, isn't it, like this, whose all sides are equal. This is a cube, but here it's not that. This cube means like the square and square root. What is a square? When you multiply the same number for twice, like 3 into 3 or 2 into 2, denoted with the exponent 2. See here, if you write 4 square, 4 into 4, that means, so when you multiply the same number for twice, it's a square, isn't it? We have learned in our squares and square root. So the square of 2 is 4, the square of 3 is 9, like that. So in the same way, in cube we need to multiply 3 times, thrice. Okay, thrice. We will not multiply with 3. I am again telling you, we are not going to multiply with 3. We need to multiply the same number 3 times, and it is denoted with the exponent 3. The power should be 3 on the top. If you see here, the power is 3. So the cubes are represented with the exponent 3. Okay, so 1 cube means 1 3 times. 1 into 1 into 1, the answer is 1. 2 cube means 2 3 times. It's not 2 into 3. I am again repeating. Look at your screen. 2 cube does not mean 2 into 3. If you write like this, it is wrong. 2 cube means 2 3 times. So 2 into 2 into 2, that is 8. Okay, 2 into 2 4, 4 2 is 8. 3 cube means 3 into 3 into 3, 27. 4 cube means 4 into 4 into 4. So this is cubes. Are you clear with this? Okay, let's come to the next topic, that is a perfect cube. How can we identify a number whether it's a perfect cube or not? Suppose I've taken out the three examples. Suppose these numbers are given, these three numbers are given, and the question is, find it whether it is a perfect cube or not. Then what you have to do is, you have to find out the prime factors first by doing a prime factorization. So let's do 64's prime factorization. We get 232's are 64. You know how to do the prime factorization, isn't it? You have learned in your previous classes. 2 3's are 6, 2 2's are 4, again 2 16's are 32, 2 8's are 16, 2 4's are 8, 2 2's are 4, and 2 1's are 2. So what are the prime numbers we got, the prime factors, it's here. So 64, by doing a prime factorization of 64, how many 2 we got? 1 2 3 4 5 6. So I am writing 1 2 3 4 5 6 2's. Now if you make a pair in square and square root, we used to make a pairs of we used to make the pairs of double the same number twice, isn't it? Here you have to make the pair of triplets 3 times if the number is same. Like here there are 3 2's, again here there are 3 2's, total 6 2's, isn't it? So that's why it has a pair of triplets, both has a pair of triplets. So 64 is a perfect cube. Yes, 64 is a perfect cube. Are you clear? If you are not clear, look further, you'll understand. Now let's do it with 512. After doing the prime factorization of 512, you know how to do the prime factorization, so I'll not go in details. So after doing the prime factorization of 512, we got 9 times 2. Now you have to write 512 is equals to how many times 2? 9 times 2. Now make the pair of triplets. 1 2 3. So all are in triplets. So that's why 512 is also a perfect cube. 64 is also a perfect cube. 512 is also a perfect cube because they are having the pair of triplets. Now let's take an example of 216. By doing the prime factorization of 216, we get 3 times 2 and 3 times 3. So 216 is equals to 2 times 3 and 3 times 3. Again here also, this is also a pair of triplet, this is also a pair of triplets. So that's why 216 is also a perfect cube. But my dears, if in case, suppose when you are doing the LCM, you do not get one of the number with the triplet. Suppose you get only 2 times 2 and 3 times 3. This is a triplet, but this is not a triplet. That time it is not a perfect cube. To be a perfect cube, all the prime factorization should be in triplets. I am again repeating, to be a perfect cube, all the prime factors, prime numbers should be in the group of triplets. Okay, are you clear? Okay, let's move to the next topic with the next video.